the influence of global value chains on industrial transformation. Next slide. The hypothesis, as listed below, hypothesis 1, will measure the attitudes towards using technology positively influences the adoption of internet-based technological innovations. Next slide. The research methodology started with the literature review, which involved looking at the previous research study concerning the subject of discussion, after which the conceptual theoretical framework was developed and the data was collected. The data, the survey collected data from 343 industrial firms located in Ogun State. The data collected was subjected to data analysis using descriptive, inferential, and factor analysis. The frequency and percentages examined the perception of the respondents on the subject of discussion, while the correlation, regression, confirmatory, and explanatory analysis examined the relationship between the constants. The data was equally subjected to statistical analysis using past least square based on structural equation model, which in turn was used to determine to evaluate the adoption rate of the industry internet-based technological induction. Sorry. Next. The result of the 343 industrial firms sampled revealed that most of the industrial firms adopted technology, internet-based technology, into their day-to-day affairs by the last 3 years, which showed that they are, instead of being the first adopter of internet-based technology, they were the late adopters. Next. The analysis showed that performance expectancy and effort expectancy and the price value were significantly influenced the adoption of the internet-based technological innovations, which with a significant level of less than 0.05. While the structural model reviewed 95.1%, which this result shows that effort expectancy is the most influencing factor that influenced the adoption of the internet-based technological innovations in the industrial sector. This is in tandem with the previous studies which emphasized the importance of user experience in technology adoption. Next slide.
You have 3 minutes.
Okay. Other challenges that hindered adoption of internet-based technological innovation by firms include infrastructural limitations, policy constraints, funding issues. Next slide. Conclusion. The study concludes that attitude to using technology, facilitating condition, service providers' credibility, performance expectancy, effort expectancy, economic flexibility, and price value influences the adoption of industrial-based technological innovations. However, the facilitating condition as a driver in the adoption of internet-based technological innovation in the industrial cluster indicated that firms recognize the useful and advanced utilities of innovation, but impeded by inadequate enabling conditions to successfully adopt the emerging disruptive technologies. Therefore, policymakers stakeholders should create a conducive environment for innovation and productivity to enhance Nigeria's industrial sector's capability and ensure sustainable development, economic development in the context of Industrial 4.0 and the Sustainable Development Recommendations, policy recommendation. The government should strengthen the industrial sector financially and technologically. They should foster technological innovation by creating an enabling environment for businesses by reducing regulatory barriers. They should equally create partnership between the government, industry, and academia. Thank you for listening.
Thank you for the presentation. You speak to time, 10 minutes, thank you. The next speaker.
I don't know if, I want to ask something. Are you available now? Are you available for a presentation now?
Maybe after this one, I'll be available. I'll have get ready.
There is no one to present again. We have.
Okay, let me see what I can do, sir.
Okay, maybe you, since you are not.
Presentation by Bamimore et al. So the presentation is on a predictive control technique for controlling the pH neutralization process. The paper also models the process for control. Yeah, the presenter identify the problems associated with pH neutralization, which is that they are complex and non-linear. The presenter also placed his own technique within context by reviewing various techniques that have been used for the process of modeling and controlling pH neutralization. The paper reviewed feed-forward neural network and also feed-forward neural network with Kalman filter. And feed-forward neural network. He also compared feed-forward neural network and recurrent neural network. The presenter identified gaps the presenter identified gaps in the
criteria allocation of stats non
So also identify gaps in literature. The paper proposed to make a review of long short-term memory network and also briefly reviewed nonlinear model predictive control. So the paper, in essence, showed how these two techniques are integrated, in which the modeling aspect of the nonlinear modeling predictive control is implemented using the LSTM, that is the long short-term memory neural network. The paper described its methodology in that the experiments were designed, data were collected, pre-processed, models were trained, tested, and then deployed in the NNPC system. From the results of the presentation, the presenter did a simulation. From the results of the simulation, he concluded that their technique is very, very accurate. It's 2 orders of magnitude better than the linear solution, and that the LSTM captured the pH neutralization process very well. In addition to that, the LSTM made a control technique very robust against perturbations or disturbance. Yeah. Thank you.
Towards addressing limited studies on policy and technology advancements and in Nigeria and gaps in literature, Olomun and others conducted systematic review of literature as well as a field study towards uncovering the determinants of internet-based technology innovation. In Nigerian industrial clusters. Disruptive technologies such as IoT, AI, artificial intelligence of things, amongst others, were focused. The study was situated within the theoretical framework, having 3 models and 7 hypotheses. The presenter gave literature, is a study of literature as well as statistical studies. The results obtained the study were presented and discussed, and various recommendations were given for government, individuals, and the scholars. However, the presenter did not make mention of an area for further research. Thank you.
Thank you. Can we appreciate our rapporteurs? Yeah, we have 10 minutes to take questions and comments. If you have questions, can you indicate by raising up your hand? And those of you online as well, if you have questions for these 2 presenters or presentation we had, just signify. I can see 1. Question, comment, 2. Any other? So there is no other. So we have 2 people having intention to ask question or make comments. So you will let us know who of the presenters you are directing your question or comments to, and then ask your question. Number 1. Madam.
Thank you very much, Mr. Chairman. I want to thank the author, congratulate the authors as well. I'm directing my question to Ojifini. All right, so your paper on pH neutralization, when I saw the topic, it actually looks very interesting, but you lost me. You were engrossed in all the equations and all that. But for a layman person, I didn't really get what you are doing. I know that all these things that we see that are working, for the control engineers especially, you do a lot of all the things I have said. But I want you to bring it down to our level, as what exactly are you trying to achieve? And all your equations, what do they mean? Thank you very much.
Thank you, sir, Mr. Chairman. My name is Fiemo Bibifa Collins, Department of Electrical Engineering, Bells University of Technology. My question is directed towards Mr. Olomun. The speaker mentioned some, it is a question with a comment. Okay, so the speaker mentioned some determinant for internet-based technological innovation, such as AI and Internet of Things technology, but no determinant which focuses on security was mentioned, because I believe that security is the heartbeat of technology. Because without security, the system can be accessed and destroyed. So my question is that, is my observation right? If yes, then I want to add a comment I want to add something to it. Cryptography, though, is a very silent aspect, but all aspects of security, ICT security, right, requires cryptography. For example, you have heard, you make use of this what do you call it? This machine, ATM machine, used in banking application. Yeah, user authentication. This is cryptography, right? You heard about voice confidentiality in mobile communication network, where you are speaking to somebody. If somebody tries to intercept and have access to communication, you will not be able to access information because of encryption, and confidentiality. So preserving confidentiality in the system. Also, if you have heard about this DSTV communication, right? Pay TV communication, right? You cannot access the information except you are a privileged subscriber. Okay, so this is just to mention a few. So I want to recommend that in your determinants, you should add cryptography to it, because no aspect of ICT and no security, whether hardware or software requirement, that does not require cryptography. Thank you.
Can we appreciate those that are asking questions, making us to get more clarification and in-depth knowledge of what is presented. So we should appreciate them. Can we appreciate them again? Thank you so very much. Ojifini and Olumu, you have 2 minutes each to react to those questions and comments. Ojifini first.
As a model, right? So also for like most systems in engineering, like the way we represent them is using equations like that. So for this MPH system, we represented the equation. That's like from theory, they derived equations in form of differential equations. So those differential equations, they capture the process dynamics of the system. So what we are doing in this process is that we are now using, so we already have process dynamics. So we have the inputs and we have the output. So in this case, the input is the base rates. If we adjust the base, the base of the system, then we expect that, okay, the pH is going to change. So the pH that is changing is the output, while the base is the input. Okay. Okay, the application in real life, like process, like control is like very important. For example, as I said earlier, in pharmaceutical industries, let's say in pharmaceutical industries, they produce drugs there, right? So, and those drugs, many of the active ingredients, they actually depend on pH. So if you actually want to make sure that the pH is well controlled so that we don't have bad drugs, then you actually have to use methodologies that will ensure that those pH are well controlled. Also in biological systems where we have like enzymes that they only be active at certain pH. So we need to ensure like good control algorithms to make sure those pH can be monitored. So I hope I tried.
Thank you very much. Your question or comment on the cybersecurity is very important. But unfortunately, the models we chose didn't look into the cybersecurity of the thing. But just as the rapporteur rightly said, that the study didn't recommend further studies. Maybe that will be part of the further studies. Thank you.
Thank you very much. Let's appreciate them once again. At least they have been able to allay our fears on those questions that were raised. And he just told us that they will look into it as further studies. So it's coming into that area. He will put it in place. The chairman of the the LOC, the committee has just come to plead with us. So, and I also want to plead with you so that we take one more person. It's Ayonlade. He's going to present online. So we still have a few minutes that we can spare. So just spare in a few minutes. 10 minutes of presentation and then 5 minutes of questions. Ayonlade, please, over to you, online.
Yes.
Okay, can you see my screen?
No, you have not shared. Okay. We can see it now.
Okay. Okay. So can I start, sir?
Yes, go ahead. We have just 10 minutes.
Okay. Good afternoon, everyone. My name is Ayonlade Samson, and today I will be discussing strategic allocation of STATCOM for power loss minimization and voltage profile, voltage stability improvement in power grid using Firefly algorithm. So this is the outline of my presentation. So power transmission networks face rising demands due to population growth and industrialization, leading to significant power losses and voltage deviations, as shown on this slide. So the lack of sufficient reactive power can lead to voltage collapse, creating supply disruptions. So excessive reactive power, on the other hand, impacts overall network efficiency. So addressing these issues can involve building new transmission lines, which is costly, or using reactive power compensators like STATCOM. So, which is shown in figure 1. So we can see and receive other PAC devices as well, such as static power compensator and unified power flow controller. But STATCOM provides a particular dynamic response in supporting voltage stability. So if you look at figure 1 shows the basic structure of a STATCOM, which consists of a voltage source converter, a DC capacitor, and a coupling transformer. So as shown in the figure, the VSC plays a critical role by converting DC to a 3-phase output, allowing the STATCOM to either inject or absorb reactive power to maintain voltage stability. So the mode of operation depends on the difference between the STATCOM internal voltage and the bus voltage, either supplying or absorbing reactive power. Equation 1 to equation 4 shows the power flow for STATCOM controller. So now to Firefly algorithm. So to find the optimal placement and size of STATCOM, so we employ the Firefly algorithm. So the core idea here, shown from equation 1 to equation 5 to equation 8, is that each Firefly is attracted to brighter or more optimal solutions. So here, brightness corresponds to the objective functions, which aims to minimize power loss. The parameters in the equation determines how each Firefly moves towards the optimal equation. Equation 8 specifically shows how each Firefly's position is updated to improve the solution iteratively. So here we present the mathematical formulation of our problems. So equation 10 defines our objective functions, which focus on the minimizing power loss across the network. Equation 11 to equation 12 present our equality constraints, which are essential for power balance in the system. Additionally, equation 13 and 14 shows the voltage and reactive power constraints that keep the solution within realistic limits. So these constraints ensure that the optimization respects both the system and the STATCOM limitations. So the test system. So in this research, the test system that we look at is IEEE 57 bus network, and the network consists of 80 lines, 80 transmission lines, 7 generators, and 50 load buses, as shown in Figure 2. Below, this is the IEEE 57 bus network that was used in this network. Now to the application of EE to the IEEE 57 bus network. So to apply the Firefly algorithm to the IEEE 57 bus network, we follow several steps. First, we enter the network data and initialize the Firefly parameters, the Firefly parameters, the alpha, the beta, and the gamma, as defined previously. We then set an initial position for each Firefly and calculate the fitness values, based on equation 8. So which represent our loss minimization function. So with each iteration, Fireflies are updated according to their fitness, leading us to the global space solution, which corresponds to the optimal location and size for STATCOM. Now on to the result and discussion. The results are summarized in Table 2, which shows the optimal position and size of STATCOM in this study. The Firefly algorithm identified bus 8 as the optimal position, with a STATCOM size of 200 MVAR. So the convergence curve, Figure 3 illustrates the convergence curve for Firefly algorithms, which show rapid convergence of this algorithm, emphasizing its efficiency in finding the optimal solution in a relatively short time. Now, Figure 4 shows the comparison of the voltage profile with and without STATCOM. Without STATCOM, several buses, like buses 25 to 30, as illustrated in the figure, like bus 25, bus 30, bus 31, bus 32, and bus 34, falls below acceptable voltage level, indicating instability. So with STATCOM, however, these physical buses are restored to stable level around 0.95 per unit, which ensures reliable power distribution across the network. So now to the power loss, the active and reactive power loss now. For the active power loss comparison, without STATCOM, the total real power loss was 112.32 megawatts. But when STATCOM were placed on the network, the total real power loss was minimized to 295.66 megaVAR, corresponding to 33.23%. So figure 6 illustrates the reactive power loss across the branches for comparison. So now to the active power losses. Figure 6 illustrates the reactive power losses pre and post STATCOM placement. So without STATCOM, the total reactive power loss was 442,000.79 megaVAR, while with STATCOM, the total reactive power loss was 295.66 MVAR, so leading to 33.23% reduction. So figure 6 illustrates the reactive power loss across all the branches. So in conclusion, this study demonstrates the Firefly algorithm that Firefly algorithm can be an effective tool for determining the optimal placement and size of STATCOM in a power network as applied to the IEEE 57 bus network. So the results show significant improvement in voltage, stability, and power loss reduction. So for future research, combine this approach with distributed generation and machine learning would further enhance grid efficiency and resilience. So these are some of our references. Thank you for listening.
Thank you, sir, Mr. Dr. Ayolade.
Thank you, Dr. Ayolade. Any question or comment for him? 1, 2. Okay, let me start from that end.
Good afternoon. My name is Yusuf Adetona from Civil Engineering Department. My question is the STATCOM, is it a product? Is it available in the market? Is it like a substitute for AVR, whereby in a new site where there is an existing transformer and other new sites are being developed, other new buildings are being developed, and those new buildings are taking their power from the existing transformer, whereby in a certain time, the building that is very far from the transformer will experience energy loss, like the current will be very low. Is this STATCOM coming as a stabilizer in terms of that transition, the distribution from the transformer to individual houses? If it is a product, is it available in the market? And I want clarification about that. Thank you.
Good afternoon, everyone. My name is Oluwatimileyin Olushola from the Department of Chemical Engineering. My question is about the algorithm used for the study. Firefly algorithm is a nature-inspired algorithm. So I want to ask the author about the comparison of this algorithm to other nature-inspired algorithms. For example, we have particle sum algorithm, we have genetic algorithm also. So how does this Firefly algorithm compare to other optimization algorithm?
Ibamimore is my name from Chemical Engineering. I think my question is in line with the last speaker. However, let me still ask it in another dimension. Now, without Firefly algorithm, how will you have solved this problem? Assuming the algorithm was not there. And like the last speaker had, how does this algorithm compare with other algorithms like a genetic algorithm and sequential programming algorithm for solving this type of problem?
My question is also in line with the algorithm, the Firefly algorithm. I would like to know what motivated you to use Firefly algorithm. So, because there are so many bio-inspired algorithms, like So, but what motivated you, and what's the difference between Firefly algorithm and other bio-inspired algorithm?
Thank you very much. I'm not asking about algorithm. You mentioned some terms that interest me. You talked about grid, talk about distribution, talk about power. Please, can you talk about grid collapse? What is grid collapse? Yeah, it's a common phrase that you hear every day now, and you are here presenting grid, so please.
The chairman said you have just 3 minutes to react to those questions. We are waiting.
Okay. Can you hear me, sir?
Yes, we are listening.
I think the first question was like, is STATCOM a device? Am I correct? Yes. Is it a product?
Yes. And is it available in the market?
STATCOM is a device. It's a device. So it is one of the member of FACT devices. And FACT devices are an acronym for Flexible Alternative Transmission Systems. And we have several families. So there are SVC, we have SVC, which is an acronym for Static Vector Compensator, we have UPFC, we have so many of them. So STATCOM is actually readily available in the market, but it's very expensive. So it's very expensive. So they are majorly used in power network to solve voltage instability. So they will be placed at a strategic position in order to solve that particular problem. So by placing them at this strategic position, they will help in stabilizing the voltage levels and improve the overall network efficiency and reliability. So I don't know if I've been able to answer that question. Then for the
Sorry, Dr. Ayolade.
Sir?
It was asked Is the device available in the market so that the new site can also utilize? Because someone make mention of you staying in a new site and power loss as houses are getting far away from existing transformer where the neighbors have been taking their source of power, source of energy. So as you are moving far away from the transformer, there will be energy loss along the way. Can this device also cater for such
yes, it can.
such energy loss?
Yes, it can. It can compensate for such energy loss. But the issue is that platform is usually placed on transmission network. Because in power systems, power system is subdivided into 3 subsections. So we have generation, we have transmission, and we have distribution. So this platform that I'm talking about is usually placed on the transmission network. And when it is being placed on that transmission network, it will be able to solve all those problems that consumers are experiencing at the receiving end.
Can it also be adopted at the distribution level?
Yes, it can also be adopted. But for distribution network, distribution level, we use this platform. They call it distribution static synchronous compensator. So we have that for distribution network. But this one is for transmission network. So the one for distribution network also exists. So we call it this platform.
The one you are actually presenting
is for transmission.
It's under transmission. Yes.
Thank you. Please.
Yes, sir.
Comparison. The algorithm issues. Can you also?
Okay, the comparison of algorithm issue that the Firefly has like the reason why why we employed Firefly algorithm in our study is that Firefly has strong convergence. So and it is good, it is suited for optimization that requires fast convergence. Then it has improved convergence also. Then so it can handle high exploration, then can also handle high complex landscapes. So it has good convergence characteristics compared to other optimization algorithm. Then in terms of accuracy, it is more accurate in locating the optimal solutions when compared to other optimization algorithm. So that's why we use a Firefly algorithm in order to locate and size the statcom that was used in this study.
Sorry, have you tried to make use of 2 or other algorithm and compare your results with this transmission line device?
That was that.
As in, subject this to this Firefly to as in another algorithm. What you have done with Firefly and also do it on using another algorithm. Have you done that before? And see
that's that have I used another algorithm to solve this? Yes, I've used other algorithm to solve this kind of problem before.
Like?
So I've used PSO, I've used Grey Wolf optimization, they have used wheel optimization, and some other algorithm.
And what are you finding?
Actually, I did not present it I did not put it in my presentation. I could have done that. I'm sorry for that. But my finding was that Firefly algorithm outperforms the other optimization algorithm I just mentioned.
Okay.
Yes.
Grid collapse.
Okay, grid collapse. Okay, I think the person that asked the question says, what is grid collapse? Grid collapse is when we have, when the power demand is greater than what the grid can actually supply. So when the demand is greater than what the grid can actually supply, then the grid will experience grid collapse. And it's not only that actually causes grid collapse. Sometimes when we have major, like maybe when we have a loss in a transmission line, because transmission network is very complex. And when there is a loss in any of the lines, it can also lead to grid collapse. So, but if there is STATCOM in that network, STATCOM will be able to, because STATCOM has the capacity of either injecting or absorbing, reactive power into the network, from the network. So if the demand is so high that the network cannot handle, so if there is STATCOM in that network, so STATCOM will be able to inject more reactive power into the network. So that in doing that, then grid collapse will be avoided. But in the absence of STATCOM, so when the demand is so high and there is nothing to inject energy into the system, then the system will experience grid collapse. So, but if there is STATCOM, the STATCOM will be monitoring the network to see if the network requires extra reactive power or not. So if the network doesn't require extra reactive power, the STATCOM will just be there. That we can say that the STATCOM is in an idle state. But if the network requires, more reactive power to be injected, then STATCOM will inject reactive power to the network, and in doing that, grid collapse will be averted.
Okay. Can we give him another round of applause? I really want to appreciate those of us that are still waiting here and listening to the presentations, because you are the one that made the day. If you are not here, then nothing will happen. So I really want to appreciate you. We are equally advised that we should be trying to monitor and control the pH so that we will not have any issue with our plants. We don't know at what level. Maybe the industries will want to buy into that if we are presented it during the opening ceremony. Maybe KBC will have even want to buy some of this. And as a matter of fact, from our communique, which I believe we reach them, they will still want to look into possible collaboration in that sense. And we are also, the government is being advised to make policies in order to adopt the internal-based technological innovation in the industries. So we have been told also that when we are in construction plants, we can integrate into our plants the system that we identify obstacles so that there are not going to be disruption of activities, or we make the construction factory safe. So you can easily recognize when there is an issue. And however, I still believe that if we can do that, we can then be tending towards a driverless situation, in which it's a matter of just deploy the tractors or what have you into the, and say this is what they are to do, and then they start operation. Once they meet with obstacles, then you have to stop. And I do believe also that those obstacles will have to be defined, well defined, because those will not be what he wants to move, that will not be the obstacles, and so the machine will not work. And finally, they say we have to prevent or reduce the loss of energy and voltage. But my question, if Anyola Day is still there, is that who is in position to acquire this STATCOM? Is it the homeowners or government that is to install it into those places? And because he was saying that it is costly, and we are talking of frugality. Thank you very much. God bless you.
I want to appreciate everybody for staying up till this time, especially for the first day of the program. The program continues tomorrow, and very early too, because we have a lot of things to do tomorrow. So I want to plead with all of us to be here for 8 o'clock. We have two plenary sessions tomorrow, and it will be very interesting. One of the sessions, Dr. Wolfram Smith will be presenting from Germany. We'll be talking an interesting topic. I want you to be here. In fact, he has to appreciate our colleagues. So please, we want to plead with you, make it a date with us tomorrow. For the students, when we finish from here, please don't go on empty stomach. Even though you are taking something, something is still waiting for you. Is that okay? I can see smiles on faces now. So I'll also be here tomorrow morning. Is that okay? For all the delegates, we also appreciate your patience around. Please, let's move there to take our lunch.